Hello, welcome to this lecture video. In this lecture video, I'm going to show you how to represent qualitative or categorical data in SPSS. All right. So now, in representing qualitative data in SPSS, we consider some important statistical tools. And the statistical tools for this task include the frequency distribution table, a bar chart, and also a pie chart in this case. Now we'll move to the SPSS. Now this is the SPSS as a software. Of course, it is an acronym for statistical packages for the social sciences. It's a statistical package for the social sciences. So now I have my data. Let's assume I have my data somewhere here. And assuming I want to impute the data manually, then I just highlight. I want to copy it from where I have the data. So I copy from the first to the last observation. I'm trying to show us different method. You could also import the data from the file. When you go to file at the top left corner, and then you import it. Of course, I save it in Excel workbook XLS. So I could just go to import data, then Excel. From here, of course, it will take it to where you have it, and then look in which folder, you check the folder, and then you could do that. But alternatively, I want to also show us how you could enter manually, which of course it requires more tasks in SPSS. So now I can paste what I've got. So you could see now as I've pasted, you could see that SPSS do not understand the first variable, second variable, third variable. That is for column 1, column 2, column 3. Remember again in SPSS, in this spreadsheet, the rows represent cases, which are represented by number 1, 2, 3, and so on. But these VAR are variables, all these VARs. So the columns in SPSS represent variables, all these columns, while the rows represent cases. So now, if we move from the data view screen to the variable view screen, you will see that at the measure, SPSS will show unknown, which is to say that you need to tell SPSS exactly what the data set represent, in particular, what each of the variables represent. And of course, you could proceed to do further analysis. So, all right, at this point, we want to move to the variable name. Although SPSS recognizes as numeric, that is for the 3 variables, they're all numeric, which is fine. But for the variable, we could change the name. This is gender, or we could say sex. And then we have fitness. And the next will be, that is from the straight blood group. So we have sex, fitness, blood group. Then what next? We don't need any decimal. If you look at it, you'll be seeing decimal places, but we're not happy with any decimal in this data set. So we'll go back to the decimal. For the width, don't bother, there's no issue at all. For this numeric, if it is not numbers, then of course it could go to maybe if it is a comma, or if it is something else, string, usually string. It could be numeric, it could be a comma, it could be dot, it could be scientific notation, it could be date, it could be dollar, it could be custom currency, it could be string. It could also be restricted numeric in the case of integer with leading zeros, but this is not the case. So what we have is numeric, and of course we're happy with the numeric. So no issues at all with that. For the width, it's just the size, so no issues with that. Decimals, we're not happy with any decimal in this case. So make sure that at the decimal part, it should be 0. So if you go back again to the data view screen, you will see that the decimals are off because we don't need any decimal. Then we go further, go back again to the variable view screen, label. The label has to do with the sex or gender for this sex. Of course, it's still the same as sex or gender. Then the fitness could be fitness level. And then again, the blood group is still blood group. Then the value, but before you do anything here, you still need to move to the measure. But of course, you can as well do it before you proceed to the measure. Now for the measure, you could see that initially it was unknown. Now SPSS is recognizing what you are doing at this point. It has changed to nominal, scale, ordinal, and so on, because we've already supplied some information. Otherwise, SPSS will not recognize at all, and it will be showing unknown as the measure. In this case, it's just a kind of classification of the variable. Is it a scale which is quantitative? It could be continuous or discrete. Or is it categorical, qualitative, which could be nominal or ordinal? Now, if you go back to the data view, you will see that the variable names instead of VAR 0001, VAR 00002, VAR 003 that we have previously have changed now to the actual variable names, sex, fitness, and blood group. So this is what we've got in SPSS. Then next, the measure value here for the first instance, the sex. Remember, we have 1 and 2, 1 and 2. So 1 represent male. We could say male, we add, and 2 represent female. We also add. So for the sex, it's either male or female. For the fitness level, we have 1, 2, 3. In this case, 1 is unfit. 2 is moderately fit. And 3 is very fit. Okay. Then the next again is blood group. Remember, they are all categorical variables. So 1, remember for the blood group, if you want to double check, you could go back over and over. For the blood group, you could see 1, 2, 3, 4, up to 4 values. So we go back again. For the blood group, we have 1 for blood group A, in this case, 2 for blood group B, and 3 for blood group AB, while 4 represent blood group O. So we have A, B, AB, and O. And then we say, okay. So at this point, you could see that sex is nominal. We're happy with that. It's not scale, it's nominal. Fitness level is ordinal because there is ranking. Unfit, moderately fit, very fit. Very fit is the highest in terms of ranking. So that's fine. When you say unfit, that's poor. Then by the time you have moderately fit, yes, that's fine on the average. Then very fit is higher than the unfit and moderately fit. So that is why it is an ordinal variable, because it involves ranking or ordering. But in the case of blood group, A, B, and O, it doesn't matter. In this case, we can't say that O is greater than AB. We can't say that AB is greater than B or greater than A. No. So it's just a mere assignment of a value to a class. That's all. Just like the case of the sex. 1 for male, 2 for female. So we are done now. We could proceed. There are no missing values. That's why the missing value, you could see that it's empty. We don't have missing value. If there are missing value, there is something we need to do further. But at this point, we'll pause here, maybe in another recording that will be made available and shared also. So of course, now we are ready. If we go back to the data view, if you want to really see what they represent, then go to the top icons and click on view. Then move down to view labels. Then you can see now we can view our labels. Male, moderately fit, unfit, and so on for the blood group A, B, AA, B, AB, O, and so on. So we have all the blood groups. So now we could do further statistical analysis. Let's assume that we want to analyze data regarding the fitness level and the blood group. We want to represent them rather using the approach we have here. Frequency distribution, a bar chart, pie chart. Let's begin with the frequency distribution. So we could deal with the frequency distribution for any of them. Let's begin with the blood group, for instance. Then all we need to do, of course, there are a lot of them from the drop-down menu that we could use, but at this point, we are not going to graph. We're not dealing with graphs. If it is for graph, you move to graph. So you go to analyze. From analyze, you go to descriptive statistics. Then you move to frequency, because we're dealing with frequency distribution. Then what variable? We could also have the frequency distribution for all the variables. First variable, second variable, third variable, all these variables. Again, display frequency tables. It could also display other information. If you go to statistics, here, if you want to work out mean and median, mode, all of that, especially when dealing with quantitative variable, that's fine. But in this case, we don't need that, so you just leave it. If you go to chart, if you want to include charts, you can indicate here maybe bar chart, pie chart, histogram, and it will be all done. But that's not what we want, so we just leave it as it is now and proceed to say OK. When you click on OK, you can see the frequency distribution here. So you could see for fitness level, 83 observations, sex, 83 observations, blood group also 83 observations. Any missing value? Not at all. And that's why you have 0, 0, all true. Then, of course, for sex, the frequency, you could see 23 male, 60 female, altogether 83. And then in terms of percentage, you have this percentage, and then the total, which is the cumulative, will be 100%. Valid percent is, of course, the same as a percent. And then the next will be the cumulative percent. This cumulative percent is this in the first instance, this percent, 27.7, then add to the next, which is plus 72.3, which will give us 100.0. That's fine. So this is similarly done for the next, where we have fitness level. So we have the unfit, moderately fit, and very fit. And of course, we work out the frequency. 12 unfit, 58 moderately fit, and 13 very fit. So you could see that the number for moderately fit is the highest in this case. And of course, in terms of percentage distribution, you could also see the corresponding result. Then we'll move on to the blood group. Blood group A, 36, blood group B, 25, blood group AB, 13, blood group O, 9. So there are more persons with blood group A, followed by B, AB, and then fewer persons with blood group O. And of course, you could see the corresponding percentage distribution. So this is how we could obtain frequency distribution for a categorical or qualitative data set. We may get this off if we want, then it will be gone. Now we could do other analysis also. Assuming we want to obtain a pie chart. So let's deal with a pie chart, for instance. And the pie chart in this case, we need a pie chart for the fitness level. We could also do for sex. We could do for blood group because they are all categorical. So the pie chart is suitable for a single variable. So we go to graph, legacy dialog, and then you proceed again. You go to a pie, for instance, define, it will take you there. We want to get a pie chart for fitness level, so we define slices by fitness level. Okay, and then we have the result. This is the pie chart. So from this chart, you can right click, move to edit, and then from the edit, of course, let me take this down. From the edit, you can now go to the top icon, elements, click on this element, show data labels. And of course, you will see the data labels. You could see 13 on fit, sorry, rather 12 on fit, 13 very fit, and 58 moderately fit. So 58 is the highest. We could also do the same in terms of percentage distribution, where we can obtain the percent. Let's go down to percentage. Still the same information as we've got. Sorry, I think we're dealing with bar chart. Sorry, pie chart rather. So we'll go to pie chart, define. Then instead of number of cases, the slices this time around will represent percentage of cases. Then you proceed to say okay. Now, this is the result. Looks very similar, but it will show the percentage. If we proceed, right click, and then click on edit, then go to elements, show data labels. So in this case, you can see that it is now given in percentage. So this is the percentage distribution of the fitness level of the individuals in this data set. Of course, you could see that the highest percentage is for the moderately fit, followed by the very fit, and then the unfit. So fewer persons are unfit in terms of, let's say, fitness level or for exercise as compared to the very fit and moderately fit. All right. So we're done with the pie chart. Let's move now to bar chart. We want to obtain a simple bar chart first. So for a simple bar chart, this is what we do. We'll go to graphs, legacy dialog, bar, then simple. Let's assume we need the bar chart for the fitness level. Define, and then what we want is fitness level to be at the category axis. If we're happy with percentage of cases, then we'll click on this percentage. If you're happy with number of cases, you could take this, either of them. And then we'll go to OK. So you could see here in terms of percentage distribution using a bar chart. Now, when we right click on the chart, you scroll down, you'll get to edit. Click on edit. And from this edit, you could go to elements. Click on elements, show data labels. And of course, clearly, you can see the result. So you could see the result in this case. Again, using a bar chart, you could see that each of the bars are proportional to the given percent. And if we're using the number of cases as they appear without the percent, of course, each of the bar will also be proportional to the corresponding number of cases. Let's say number of people in this case, how many people are unfit, how many people are moderately fit, and how many are very fit. It could also be the case of, let's say, patients in a hospital in terms of health records, where we could have the number of patients that are unfit for maybe they went for a medical checkup just to double check if they are fit for a particular task or not. And then the doctor could declare them unfit, could declare them moderately fit, it could also declare them very fit. So we could see that the highest number is still for the moderately fit, followed by the very fit, and then the unfit, using a simple bar chart. We could do the same also for the rest of them, that is the blood group, and also for the sex, male and female. Now we want to obtain what we call the clustered bar chart. And then the next will be the staked bar chart. So for a clustered bar chart, what do we do? Go to graphs. Then from graphs, we move down to legacy dialogues. And then click on bar. Then we choose cluster, define. And how do we want it to be? That is our area of interest here. So it could be number of cases if we're happy with that. It could also be percentage of cases. So let's deal with number of cases. Now, we might want to check the fitness level. So in this case, the fitness level are the category axis. Then we may also go to sex, for instance. So we define the clusters by sex. And then we'll proceed to say, okay. So you can see now, clearly here, the bars have been clustered. So for the unfit, we have the number of males and the number of female. Also for the moderately fit, we have the number of male and female. And for the very fit, also the number of males and female. Again, if you right click, you go to edit, and then element, show data label. You will obtain the actual label. So 3 males and 9 females unfit, 18 males and 40 females moderately fit, 2 males and 11 females very fit. So we could see that from this population distribution, there are more females than males. All right. Again, as a matter of choice, you could play around as much as you want. We go to same clustered, and then this time around, let's take this back also. We want now the blood group. Let's assume we want the blood group to be at the category axis, and then we want the fitness level to be the cluster. So we define clustered by fitness level in this case. While at the category axis, we have the blood group. Let's assume we are happy with percentage of cases. We could also go to number of cases, no issues. So let's take percentage of cases. And then you could see the result in this case. For the unfit, you could see here, those with blood group A, how many are unfit, how many are moderately fit, and how many are very fit, and so on till blood group O. Again, if we want it, we can interchange them to obtain same cluster bar chart. We go to cluster, define, and then we take this back also. Then you bring in fitness level at the category axis. You go to blood group to be at the cluster. Let's assume this time around, we want number of cases. And then we could say, okay. And you could see the results now. So this is the result. You could copy this if you want. You could copy the graph, right click, then you go to copy and paste it maybe in a Word document, or you could save it anywhere as the output. Alternatively, you could also go to file with no issues at all. So you could see the result very clearly. This is the output. We have for the unfit, those with blood group A, B, and O. For the moderately fit, those with blood group A, B, and O, and so on till the last one, which is the very fit for blood group A, B, and O. So this is called a cluster bar chart, because you could see that the bars are being clustered. What if we want to deal with multiple bar charts? Let me get this off. For multiple bar charts, we still go to graph, legacy dialogues, bars. Sorry, for stake, rather, we call it staked bar chart. This cluster is multiple bar chart. We could also call multiple bar chart. We have component bar chart, in another word, component bar chart. The component bar chart is also known as the staked bar chart, while the multiple bar chart is clustered bar chart. But in SPSS, the cluster bar chart represents the multiple bar chart, while the staked bar chart represents the component bar chart. So don't be confused in case you come across those alternative terms. So we go to define. From the define here, let's assume we are happy with the fitness level and then the blood group. So the fitness level is at the category axis. The blood group is being staked. So they define states by the blood group. And let's assume we're working with percentage of cases. Okay. And then we could see the results. So it's been staked. In this case, we stake it. That's why you see component by component. Instead of multiple bars, we have components bar chart. And this component bar chart is also called staked bar chart in SPSS. So this is the result. Again, if you right click, you go to edit, elements, show labels, and then you could see the result very clearly. In this case, the percentage. You could see the percentage for blood group O that are unfit, and so on. The percentage for blood group AB, B, and A, and so on for the moderately fit, the very fit. So you have the respective percentages here. All right. So we have seen how we can use this approach to represent data. Let's see if there is anyone that is still left from among the ones we have dealt with. We've used frequency distribution, we've used pie chart, we have also used the bar chart. So I must say thank you so much for your attention. Thanks for watching my video. Please, if you could also subscribe to my YouTube channel, and where possible, you drop a comment, you could leave a comment, or you could also like the video. That would be very great. Thank you so much.